Splitless injection is an excellent technique for performing trace analyses. But to get the most out of a splitless analysis, it's important to optimize your system. But what should you optimize to get the best results? We are glad to be back for this ResTech tip, and we're going to show you how to optimize your splitless injections to achieve high-quality chromatography. Let's start with liner selection. Choosing the right liner can drastically improve both analyte recovery and injection-to-injection reproducibility. For splitless analysis, you need a liner that maximizes homogeneous vaporization, is inert, and has a tapered bottom. A single taper liner with wool or a double taper cycloliner are great choices. The extra surface area from the wool or the corkscrew aids in vaporizing and mixing your sample with the carrier gas. It also helps to trap non-volatile material, protecting the column. Liner deactivation is important for splitless injections. The longer inlet residence times could lead to analytes interacting with active sites within the liner and inlet. Selecting a well-deactivated liner reduces adverse effects from these interactions. Lastly, the tapered design at the bottom of the liner helps to direct the sample towards the column and reduces contact with the base of the inlet where analyte breakdown can occur. Next, we'll optimize the inlet temperature. You want the temperature to be high enough to achieve sufficient vaporization, but low enough to not cause excessive activity. 250 degrees Celsius is a good starting point, but you may need to adjust this temperature to achieve the overall best peak responses for your analysis. So now, how do we optimize our splitless hold time? Well, you want a hold time that's long enough to allow the complete vaporization and transfer of analytes to the column. But one that's too long can cause excessive solvent peak tailing, leading to interference with early eluting analytes. A good rule of thumb is for the carrier gas to sweep the total liner volume between 1.5 and 2 times. ResTech's EasyGC flow calculator can calculate the ideal hold time range for you. And finally, initial oven temperature. Since splitless mode has a slow flow rate, band broadening will often occur as analytes diffuse within the inlet. To help recondense these analytes at the head of the column, you need a lower oven temperature combined with an initial hold time that matches your splitless hold time. The exact temperature to use depends on the volatility of your analytes. If they are relatively volatile, the initial oven temperature should be below or close to the boiling point of the solvent. If they are significantly less volatile than the solvent, higher initial oven temperatures can be used. There you go. You've optimized your splitless injection and are ready to start your analysis. If you have any questions, we're here to help. Leave a comment below or visit us at restech.com. And if you would like to see more videos like these, please like and subscribe. And we are really looking forward to seeing you for our next ResTech tip.